Hi, thanks for joining me today. I'm going to be going over a problem which was previously set as an interview problem for entrance to maths at Oxbridge, so Oxford or the University of Cambridge. Okay, if you haven't seen my videos already where I talk about what it's like to do maths at Oxford, or the one in which I talk about interviews at Oxford, I'll leave links to both of those in the description below. But today we're going to be stating and solving this problem here. We want to know how many solutions are there. In other words, how many x are there in the reals that satisfy this guy here. So e to the x equals kx. Here k is just some real number. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself. And I'm going to jump straight into a solution. Okay, so what we want to do to solve this problem is split it into three different cases. Firstly, when k equals 0, secondly, when k is less than 0, and finally, when k is greater than 0. So let's look at the case where k equals 0 first. This is a very straightforward case. If k equals 0, then this equation here just becomes e to the x equals 0, and we know that this has no solutions because e to the x is always strictly positive for real values of x. Okay, so this leads to no solutions, so that's fine. Now what we want to do for the next two cases, i.e. when k is negative and k is positive, we actually want to sketch a graph to help us. So if we sketch the graph y equals e to the x, and we sketch the graph y equals kx, then we can look at any points of intersection, and each point of intersection will correspond to a solution to this equation here. Okay, so let's look at the case when k is less than 0, and let's sketch a graph. So this is our x-axis, this is our y-axis. So if we sketch the graph y equals e to the x, that looks something like this, like so. And if we sketch the graph y equals kx, now remember k is a negative number, we don't really know what it is, but it's going to look something like this. So it's going to come from the top left quadrant to the bottom right quadrant, because the gradient k is negative, and we can clearly see there's always going to be just one solution. Okay, and that solves the case k is less than 0. So when k is 0, there are no solutions, and when k is negative, there's exactly one solution. Now let's look at the case where k is positive. Okay, so now we're going to focus on the case where k is positive. I've sketched the graph y equals e to the x. And now when we have k positive, y equals kx is going to be a line passing through the origin from the bottom left quadrant to the top right quadrant. Now we can see just by looking at this graph, if k is a really small positive number, then the graph is going to look something like this, like so. Obviously that's a pretty horrible straight line, but you know what I mean. It's a straight line, but there's clearly no points of intersection. The next thing you notice is that if k is really large, then there are going to be two points of intersection. So it could look something like this, say. So that's a possibility. And we can see if k is just right, then there's going to be just one solution. So if we just touch this graph here, maybe there, just like so, something like that. Okay, so we can see if k is bigger than this, whatever this sort of, if we call the value of k where there's one solution, if we call that k naught, say, if k is bigger than k naught, there are going to be two solutions. If k is less than k naught, there are going to be no solutions. And if k equals this nice value here, then we're going to get exactly one solution. Obviously, the question is, what is k naught? I.e., what is this value here? Well, so let's call this point where it just touches, let's call the x coordinate x naught. So what do we know about x naught? Well, firstly, clearly the two lines are touching. So this line here that we're considering is the graph y equals k naught x. Okay, where k naught is this kind of nice value you want to work out, because then we know if k is bigger than k naught, there are two solutions, k less than k naught, 0 solutions, and if k equals k naught, then there's exactly one solution. Okay, so what do we know about x naught here? Well, these two graphs touch, so they intersect at the point x naught. So therefore we have the e to the x naught is equal to k naught times x naught, like so. But also, because they just touch as opposed to sort of intersecting, we also know that their derivatives are equal at this point. So what's the derivative of e to the x? Well, that's just e to the x. And then evaluating that at x naught gives us e to the x naught. And the derivative of this line here, so y equals k naught times x, is just the constant k naught. So we have the e to the x naught is equal to k naught. So we have these two equations here. Now clearly we can just use this second equation and plug it into the top one to give us that k naught is equal to k naught x naught. And of course, just dividing both sides by k naught is going to give us that x naught must equal 1. So at this point here, x0 is equal to 1. Okay, so now that we know that x0 is 1, we can just plug it into either of these equations we want. Let's plug it into this one here, and then we're just going to get that e to the 1 is equal to k0, and that of course just tells us that k0 is equal to e. So this special value k0, I want to say unsurprisingly, because e is always cropping up in maths, we get that k0 is equal to e. So if k is a positive number bigger than e, then we're going to have two solutions. If k is a positive number less than e, we're going to have one solution. And if k equals e exactly, we're going to have just one solution, and that one solution is x0 equals 1. Anyway, I hope you have enjoyed this video in which I solved a cool interview problem. If you are doing interviews at Oxford or Cambridge for maths or anything else, best of luck. I'll catch you in the next one. Have a great day.